Dear students, we will continue. We are studying about the hydride reaction of nitrogen with hydrogen in P block elements, nitrogen family. So we have studied that the hydrides of these elements are NH3, then PS3, then ASH3, SPH3, then BiH3. These are the hydrides. Now let us study some properties of these hydrides. First is bond angle. Bond angle. As we go down the group, the bond angle it decreases down the group. So we will study examples of this, that is PS3 and NH3. The size of the nitrogen is small here and the size of the phosphine here, phosphorus, is large. So you see the molecule of the phosphine, it is like this, having a lone pair of electrons, and ammonia is also having one lone pair of electrons, and these are the three bonds. So these three bonds are nothing but the bond pair, and there is a lone pair here. So there is the repulsion between the bond pair and the bond pair. Okay, same is here in case of phosphine, but due to the small size here the repulsion will be more, and here the repulsion will be more, here it will be less. So what will happen? The angle will get reduced in this case, and here the angle will become large. So we can say the phosphine is having bond angle more as compared to ammonia. Okay, hope you have understood. Then next is next property of this hydrides. We have to study that what is the thermal stability of these hydrides. Okay, thermal stability. Thermal stability of the hydrides, you can write the hydrides like this, and what you see that the ammonia is the most stable hydrides as compared to the other hydrides, and the trend is like this. You can just explain that these both elements, they are of almost same size, whereas here bismuth is having large size and hydrogen is having small size. So overlapping here will be more, the extent of overlapping will be more here, the extent of overlapping will be less. So the stability here it will be more and here it will be less. That is the reason. So what you can say that, so as we go from the nitrogen to bismuth, we see that the bonds become weaker and weaker as extent of overlap it decreases. The next property is basicity. Basicity, what you see here, the basicity it decreases in these hydrides, and acidity it increases. So acidity increases and basicity decreases. So in case of nitrogen, you have the hydride NH3, it has lone pair of electrons, so it can easily donate the electron as compared to the other elements. Why? Because the lone pair of electrons, they go diffusing as we go from nitrogen to bismuth, so it will be difficult to donate. Whereas in case of acidity, though in both the things we see that the common thing is that the molecular size of these molecules it is increasing. Okay, but in case of if it wants to donate the electron, it will be difficult as we move from here nitrogen to bismuth. But the bond between the element and the hydrogen atom it easily breaks, and therefore the acidity increases. है ना. Suppose arsenic, antimony, the bond between this, it can be easily broken and released as H plus. So acidity increases in this case. That is, if we move uh, from nitrogen to phosphorus. Now we will study the compounds of nitrogen. Okay, nitrogen compounds. So first is dinitrogen, that is N2. So we will see the first the preparation. Simple preparation NH4Cl, if you react it with sodium nitrite, that is aqueous medium, you will get N2 plus water plus its chloride, sodium chloride. So this is the lab preparation. Then second, this is the lab preparation. Then next, you can prepare it from ammonium dichromate. Just to heat it, thermal decomposition, you will get N2 plus H2O plus CrO2, AO3. Then next also thermal decomposition of barium azide. We have the compound NH3, this we call it as ammonia, but if it is the opposite, HNO3, HN3 is called as acide. So if this hydrogen is replaced by barium, then it will be barium acide. So this compound, if you heat it, you will get barium plus nitrogen. So these are the certain methods of preparation of nitrogen, dinitrogen we call. Then properties. First is Haber's process. It has the tendency to react with hydrogen and form ammonia, and the condition is that heat at 773 Kelvin and give some pressure, then you will get ammonia. It can react with oxygen and form nitric oxide, that is the brown gas. The color of this gas is brown. It can react with metals like lithium and form lithium nitride at high temperature. So this is the compound nitrogen, and it finishes. Next compound is ammonia. NH3. So simple preparation first we will see. You can prepare it from NH2CO, NH2, which is the name of the compound is what? Urea. And then react it with water, you will get ammonium carbonate. Then this ammonia can again decompose to ammonia, further decompose to ammonia and water and CO2. So you can see this compound, it gives three compounds. You can see ammonia, water and carbon dioxide, and see the nature of these compounds. This is base, this is acidic, and this is neutral. So is it interesting? Isn't it interesting? Urea is giving three compounds. One is base, and the other is neutral, and the third is acidic. Next method is Haber's process. We already seen in the properties of the nitrogen. Then in small scale, you can prepare it from the ammonium salts. For example, ammonium chloride plus if you react it with the base, then you will get ammonia plus water plus chloride, calcium chloride. Or if you react it the ammonium sulfate with sodium hydroxide, you will get ammonia plus water plus H2SO4. Sorry, Na2SO4. है ना, सोडियम है ना यहाँ पे. Now properties. Properties. Properties of ammonia. It is a weak base. It is highly soluble in water. If you react ammonia plus water, then you will get NH4 plus and OH minus. So this is what? This is basic in nature. Okay. So, but it is a weak base. Then it can form ammonium salts when it react with acid. For example, if it react with HCl, it will be NH4Cl. If it will react with sulfuric acid, then ammonium sulfate will be formed. Then it can precipitate the many metals like this metal salts. It can precipitate as its hydroxides. You know. Then next property, it can behave as a monodentate ligand. The ligands you will study in the coordinate compounds. Okay, it acts as a strong ligand if it combines with copper, cobalt, cadmium, iron, and if it combines with chromium and nickel, then it behaves as a weak ligand. Then it has the property to this property is nothing but to link with the metal atoms, and it can link with the metal atoms through coordinate bond. Okay, so this property is very useful to find the to detect the metal ions like copper, copper ions can be detected. How? If you react the salt with the ammonia, aqueous ammonia, so what will happen? It form a complex, means it can link it with the metal ion and form a complex, and this complex is deep blue in color. So due to this deep blue in color, you can detect the copper. We can say that the copper is present. Now some next topic is oxides of nitrogen. Oxides of nitrogen. We have many oxides: N2O, NO, NO2, N2O3, then N2O4, N2O5, and the oxidation states are from +2, +1 to +5 in these oxides. Okay. So let us see the preparation of these oxides. How to prepare these oxides? So first is N2O acid. N2O, if you react ammonium nitrate, that is if you thermal decompose, then you will get N2 and H2. Then NO, NaNO2 reacts with FeSO4 and H2SO4. Then you will get NO plus Fe2SO4 thrice and NaHSO4. Also water molecule will be also there. Then NO2, if you again thermal decompose lead nitrate, you will get NO2. N2O3, just react it with N2O4, NO and N2O4, you will get N2O3. Then N2O4, if you cool it, then you will get N2O4 dimerize, and if you will heat it, then you will get back NO2. Then last is N25. Just react it with phosphorus oxide, that is P4O10, then you will get HPO3 and N2O5. So these are the preparation of the various oxides of nitrogen. Now the next topic is very important, that is the structure of nitrogen oxides. Okay, structures. Of various oxides. First is N2O. It is having linear structure and double bond O, double bond N. It is having linear structure. Then NO. NO simple and double bond O. Okay, it's not triple bond, it is N double bond O. Okay, so it is a odd electron species having one electron on the nitrogen atom, like this. This is the Lewis structure of this. If you want to draw the structure of the NO, this can also be drawn. You know to draw the Lewis structure, you can draw it. Then NO2. NO2 and double bond O, then single bond O with 6 electrons, that is 3 lone pair of electrons. This will be negative. It is having also 1 electron, so this is a odd electron species also. But it is light. It's better to draw like this because it is slightly angular. Okay, so its resonating structure will be N double bond O, double bond will come this side and single bond. Okay, so this is the structure of NO2. Now other structures, let us go to N2O3. N2O3 structure. So first now 2 nitrogen atom is there, so first you join these 2 nitrogen atoms. Then in one side you will be having double bond O with 4 electrons oxygen, and one will form double bond O and the other will form single bond. So whenever there is single bond, you will make 3 pair of electrons, and whenever you are having double bond, you will make 2 lone pair of electrons. Okay, so this is the structure of N2O3. Then N2O4. just increase the number of oxygen atom. This and single bond and double bond O, then single bond O, double bond, single bond O, then double bond O. So this will be N2O4. Okay. Next. Next N2O5. N2O5. So again one more oxygen here to increase. So how we can increase? Just have to put the oxygen in the middle of the two nitrogen atoms. Then again the same structures, double bond O, single bond O, single bond O, double bond O. Draw the lone pair of electrons in each oxygen atom. Okay. So this is N2O5. So these structures are very important, children. You must go through these structures, very important. Okay. Then one question is very important in this nitrogen compounds, NO2. NO2. Sorry. NO2. Why it dimerizes? Dimerizes means joined together. This is because nitrogen in this compound contains odd number of valence electron. That is, it has a single electron. It dimerizes to N2O4. So what will happen on dimerization? Here there is odd number of electrons. So it will become even number of electrons. So it tries to go to the even electron species as compared to the odd electron. Now next, compounds of nitrogen will, more compounds of nitrogen are there, that is HNO3, but it is nitric acid. Preparation. Okay, this will continue in the next class.